Hi, this is part 1 of chapter 3 on sequences. So in this part, we're going to look at the basic sequences, what basic notation we need, focusing on the expression for the nth term and also some of the first n terms. So for basic notation, A always represents the first term and D always represents the difference. So if I just say have the sequence 3, 5, 7, 9. Here A will be 3 because that's the first term, and D will be 2 because each time it's going up in 2. You need to know how this relates to like any term you want. So the first term, we could simply represent that with A. The second term would be A plus D. The third term would be A plus 2D because each time we have one more D. The fourth term will be A plus 3D. For the nth term, it's going to be A plus n minus 1D. So always remember, this number here sort of lags one behind the term you want. So for the 100th term, you'd have A plus 99D. This different GC notation, but it's important you get to grips with it and feel quite comfortable using it, as it makes a big difference in how the maths will apply to you and how smoothly your answers will come out. So do try and use using this notation. We'll look at mainly going to be some new stuff. So say we have this sequence, and to give all the numbers from 1 to 100, we're looking at what technique we can use to solve this. Okay, and for all these questions using arithmetic sequences, which where they go up by a certain number each time, we use the exact same trick. What you want to do is just add together the first and the last term. So 1 plus 100 gives me 101. I then repeat that for my second and my second to last term. So 2 plus 99 is also 101, and then so on and so forth. You can see that every single pair of numbers will give me 101. So if we work out the sum, we have 101. And like I said, it's every pair of numbers to give me 101. So if we have 100 numbers, that means we have 50 pairs. So the total sum of the numbers from 1 to 100 will just be 101 times 50, which comes out at 5050. This is kind of the key idea. We'll look at some formulas to do with this later, but for the time being, it's kind of important you sort of understanding how the trick works in terms of proving it, which you do need to know, and also applying it for slightly more weird questions. So let's look at this same question here, or the same type of question. We have another sequence going from 3 up to 55. However, we don't know how many numbers are in the sequence. So I can do the same trick and it'll totally work. 3 plus 55 is 58, 7 plus 51 is 58, and so on and so forth. But I don't know how many 58s I'm going to have. Okay, so we need to be able to work this out. What we're going to do is we're going to work out what we're going up by each term. Okay, that is fairly obvious. Each time we are going up by 4 terms. So then the question is, how many jumps of 4 have I made? Best way to work it out is just do the difference in the terms. So 55 take away 3 and then divide that by 4. That gives me 13. Now, here's the obvious mistake. That is not saying there were 13 terms. That is saying they are 13 jumps. Okay? So it basically means I had 13 plus 4s. And as we saw from the basic formula, A plus n minus 1D, this number always lags one behind the number of terms we have. So because that gave me 13, that meant that I actually had 14 terms. Okay? You can actually test this out. Basically, what we've actually solved is we've actually solved A plus n minus 1D equals 55. We then got n minus 1 to give us 13, so n was 14. So, coming through all that, we've worked out there were 14 terms. Therefore, that means there are going to be 7 pairs. So the total sum will be 58 times 7, or whatever that equals. Okay? We can look at this both ways. We also have the question where we've got some amount of terms, but we don't know what the last term is. And we can do the exact same trick. So in the previous question, what we basically did, or what I should have done from the start, was just use this formula. A plus n minus 1D is 55. Fill in A and D, which were 3 and 4. Yep. And then solve from there. Here, we're going to do the exact same thing for this question. To work out my 20th term, I'm going to use the formula for my 20th term. It will just be a plus 20 minus 1d. Okay, so a was my first term, which is 11. 20 minus 1 is obviously 19, and d is my common difference. And each time here, we can see we're going up in 5s. So my 20th term will be 11 plus 19 times 5, which is going to be 106, I hope. So I know my last term is 106. So now to the exact same trick before. Okay, I've now got the last term. That means I can now work out what each of the pairs add up to. Adding these together, I know that every single pair is going to be 117. I could work out more terms here, but I don't need to. So each pair is 117. We had 20 terms. That means we would have had 10 pairs. So therefore, that sum will be 1,170. Okay, and so we'll see formulas that help you with this, but I genuinely think it's important to actually know how this trick works. Again, for the harder questions, also for the proof as well, know where it all comes from does help you understand what's going on and why we do what we do. So, can we just head to page 64 and try these questions? Okay, having the answer to the bottom of the page while you're working through on the OneNote file. Okay, I'll move on. Okay, so we're going to throw some notation to that now, basically how the sum works and how it could have made these questions a bit easier, although both has will of course work. So we saw notation at the start where we had the nth term was given by this formula here, which is actually given in the formula booklet. Let me check that. Okay, this formula is not in the formula booklet, but it is kind of referred to. You do need to know it. It is implied that you do know it. So this you do need to remember. So we can use that to get an expression for the sum of the first n terms, okay, which is this here. Let's break it down. This n over 2 just represents how many pairs we have. Okay, number of terms halved, number of pairs, and then it's just going to be the first term and the last term, what we've been doing. Okay, in the books they always use L for last term. You can use the nth term. It gets a bit messy having too many n's, so it's best to use L for last term. This is in your formula booklet for what it's worth. Okay. However, this form isn't really used. Okay, you don't always know what L is, and sometimes you're not really given it. Long story short, you should not rely on this formula. Okay. What they do is they basically combine this formula with this formula. So your nth term, like I mentioned a second ago, can also basically be thought of as your last term. So I can basically replace this L with everything here. So now the sum of my first n terms is n over 2 a plus. I'm just plugging in everything here. I now have this expression here. Simplifying it down, we get n over 2 2a plus n minus 1d. Whenever you see a summing question, you always want to use this formula. And again, it is given to you in your formula booklet. Okay. Before we move on with this, you also have this alternative notation that I'll cover out in a future video that means the exact same thing. So you see that doesn't mean the exact same thing. I'll cover it more later on though. Okay, I'll go for an exam style question, showing basically how they can use notation and also some other questions you commonly see. So first, just a question you commonly see is when you're given two random terms and they need to work out what the first term or the common difference are. For this, we're going to use notation we know. We know for any term, we'll call it nth term, that is just a plus n minus 1d. And again, you do remember this. So for the second term, it would just be a plus 2 minus 1d or a plus d. Again, the number of d's always lags one behind what term you want. So for the fifth term, that would be a plus 4d. Next, you plug in what we know. This second term, this just equals 14. This fifth term, this just equals minus 1. And here we have a simultaneous equation. Let's label them 2 and 1. Let's just do equation 2 minus equation 1. The a's will cancel out. I've then got 4d minus d, which gives me 3d, and minus 1 take away 14 gives me minus 15. Therefore, my common difference was minus 5. I also need a, so let's just copy the first formula down again and substitute in what we know. So a minus 5 equals 14, therefore a equals 19. Okay, not too hard, but does often come up. Is a skill you should remember and you should need to know. Okay, I want to go slightly harder now. So, find the least number of terms required for this sum to exceed 2,000. So, we're going to use this formula, always this formula for what it's worth. And first of all, we're going to set it equal to 2,000 and see what that gives us. So, let's copy it down. Again, I write n over 2 rather than half n, but that's just my personal preference. And let's write down what we know. So here, we know that a equals 4 and d equals 5, so it's going up in 5s. And I want to write something for my Sn. Okay, I could use an inequality. So I could say I want, let's write it down, n over 2, 2a is 8, plus n minus 1 times 5. I could say I want that to be greater than 2,000, which is technically true. It's actually easier if we just solve it equal to 2,000. And then from there, we can get our term from that. So let's go ahead and do this. So we have an equation here, okay? All we're going to do is expand out all the brackets, try and simplify it down, and try and make it look a bit nicer. So first, let's expand the brackets on the inside. So I've now got 5n minus 5 from doing this here. I've got 8 minus 5. That can just simplify down to a 3. Equals to 2,000. Let's expand this bracket as well. So I've now got 5n squared over 2 by doing that times that. And this times this will give me 3n over 2 equals 2,000. I don't like fractions, so let's times the whole thing by 2. And to solve any quadratic equation, you want to solve it equal to 0. This, you just plug in calculators, use quadratic formula, so let's do that. Okay, so that's been plugged in. If I solve that, I either get n being 27.98 with a plus, and if I change that plus to a minus, I get minus 28, which of course I can't accept because you don't have a minus to a sequence, which just only go up. So when I have the 27.98 fifth term, that would equal exactly 2,000. However, I want it to exceed 2,000, so therefore I want the next biggest number. So n equals 28 will be the first term that exceeds 2,000. That's why it was important here that I didn't round this up to 28. Because if I did, then I'd go above 28, which is going to be 29, which would not be right. Okay? So at the advanced ends, a lot of questions involve working out how many terms you have, which then always results in getting a quadratic equation to solve. Okay, that is fairly common. You can have the same type of question where you're working out either the first term or the common difference. That's the exact same idea, except it won't form quadratic equations, so it'll be a little bit easier. Okay, I've got some questions for you to try here. These questions from the book. If you want a hard question to try, there's some example ones here as well. Okay, that is it for the first part. Hope that helped, and good luck.